So to nobody's surprise, DeepSeek V3.1 has been a major hit. Well, I lie, because DeepSeek V3.1 sort of had the same effect as GPT-5 did in its US releases, in that spec for spec, it was very impressive. It was able to do a lot of the things that GPT-4 did better, but really it was the spec increases, the incremental increases, the incremental improvements in what it was already doing slightly better that was the highlight. And if you watch the GPT-5 release video, it was basically the OpenAI team trying to sell GPT-5 as a better tool to use for coding than for anything else, right? Which I think, to be honest, if you're the kind of person that's only looking to get wowed by these new model releases, you're going to be pretty disappointed with V3.1, which again, like GPT-5, was a bit disappointing. It didn't make any groundbreaking new innovations. But if you pay attention, if you want to follow the trend, there's big things brewing under the surface, right? And the battlefield that these AI companies are on right now is no longer the battlefield of trying to wow the world with flashy new features. It's a battlefield where the ammunition is numbers. And the one kind of number that matters the most to any company and to any individual that is going to be using these tools out there is the one that I think DeepSeek is going to be winning on, right? Let's get into what DeepSeek V3.1 actually is. It's a slight update on DeepSeek V3. It uses 685 billion parameters compared to, I think, the 671 billion parameters from its past model. It is not a reasoning exclusive model. It is capable of doing chat-style inferences together with reasoning-style inferences, so that's actually pretty impressive. It is also a model that relies on a mixture of expert-style architecture. Mixture of experts is a pretty important architecture to understand, because this is sort of the thing, the secret sauce that allows these frontier models to scale big while still making inference manageable. Because think about it, right? If every time you asked one of these AI models a question as simple as, hey, what color is a typical banana? If all of the nodes activate at once, if all of the 685 billion parameters were to get activated, then that would be like steering a tanker, a giant oil tanker, to answer a really simple question like, what is the color of a typical banana? So instead what happens is, for the mixture of expert architecture, there is several underlying models, there are several underlying expert models, and a gating network that routes the request to the appropriate model so that only a small subset of the parameters get activated with any new request. That is the kind of architecture that DeepSeek V3.1 is built on. That is the kind of architecture that a lot of these newer versions of large language models are built on. And this allows only 37 billion parameters to be activated per token, which is pretty awesome because this allows for very efficient inference. Now let's talk about efficiency for a bit, right? Because this is the game that China is absolutely winning on. Because per token, for the latest models by the US grown companies, for example, Anthropic's Claude Opus, it will cost you between $10 to $15 per million input tokens. And obviously output tokens are more expensive because the AI works to create and generate these tokens. It costs you about $30 to $50 per million output tokens. Guess what that number is for DeepSeek V3.1? Per million input tokens, DeepSeek only consumes 56 cents, and it consumes $1.68 per million output tokens. That is 70 times more efficient, 70 times more cheap than the standard proprietary models that are being shipped from these US companies, from these US market leaders, right? And this is particularly important to pay attention to because this is the pattern that we can't be skipping. This is the underlying direction in which the AI wars are going right now. It is no longer about wowing new companies and wowing the world and wowing customers with brand new features and brand new capabilities. There's not going to be a studio gamification of videos or images anytime soon, right? The thing that is going to get users to stay and to commit to AI models is how cheaply can you get the things that you're already doing done now. And I think DeepSeek V3.1 has a tremendous advantage when it comes to that. And there's a couple of reasons why it's able to do so efficiently, but before I get into those, I do want to point out, I do want to address some concerns you may be having, right? You may be thinking that, oh, the reason it's able to do these inferences so cheaply is because it does a half-assed job of it. Well, not really. Of course, Claude Opus 4, Anthropic's proprietary frontier model, at coding task, which is, I think, at this point, the most lauded and the task that's sort of put on a pedestal when it comes to benchmarking the performance of AI models. So it does the thing that every other AI model wants to do better than them, which is a great signal that this is a very capable model. The other thing to keep in mind is that DeepSeek's V3.1 is actually built, custom engineered to do inference better on AI chips, next generation AI chips that are homegrown in China. I'm talking about your Huawei Ascends. I'm talking about your Alibaba Hangguang and other chips that are being developed locally within China. Now, this makes a huge difference, right? Because part of the reason why inference is so expensive on these American-grown AI models is because they are doing inference on these NVIDIA chips. And it's not very simple to swap out one chip for the other, right? Because it's not just the hardware components. A lot of the software is also tailored to specifically NVIDIA chips. For example, when you come out with a model, you have to use this framework called TensorRT that optimizes the model for inference specifically on NVIDIA chips, right? So the architecture baked into these models will limit the kind of chips they can run on. And if China is able to develop more efficient AI models that are baked to run on homegrown Chinese chips, then that is a big thing. That is a big scary flag, red flag for NVIDIA to be scared about. Genuinely. That's the boogeyman for NVIDIA because not only are they going to be losing out on the market share to China, but now you have all these open source, open weights that are open source under the MIT license, so that is an extremely permissive license. You have these open source models that are coming out of China that are trained to work on Chinese chips, that are going to be outperforming these American models that are trained specifically to work on NVIDIA chips. That is not good news for NVIDIA. That is not good news for the American AI companies. So this really does feel like red alarms if you're going to be working at a chip maker that is US-based, if you're going to be working at a team that develops these frontier models at any US-based company. But if you're an end user that is expecting to just get wowed by, oh, what's the next groundbreaking thing that these AI models are going to be able to do? You're not really going to be seeing the waves. You're just going to be seeing ripples, and you're going to be ignoring these developments. But these are big developments. These are ground-moving developments. I think NVIDIA needs to really rethink its strategy, and I think NVIDIA really needs to think about the cost piece here. Obviously, a lot of these Chinese chip manufacturers like Huawei and Alibaba are getting subsidized by the Chinese government. And the other thing to keep in mind is a lot of these big tech corporations that are based in the US are very frenzied about this idea, about this holy grail of bringing about AGI, which, to be honest, is even like, what is it even? Right? I'm not saying it's a wild goose chase, but it's a continuously moving goalpost. There is no benchmark that can definitively say, yes, we've achieved AGI. It's a continuously moving goalpost. Even the ARC AGI benchmarks are a set of human design tests that sort of test an AI system's ability to do human-like tasks, right? It is not a definitive benchmark. So it's a moving goalpost that these US-based tech companies are chasing. But in China, these companies care about integrating these AI systems into already existing processes that happen within the Chinese economy to make those processes efficient. That is the goal with Chinese AI development. And that is a much more practical and serviceable goal. And that is also, if you understand, that's also like when you have a very practical and attainable goal, you can kind of orient your resource allocation to achieving that goal. And you don't have to overpour capital for servicing a really lofty, possibly unattainable goal. And you have to understand that a lot of that research, that R&D cost, gets baked into the cost of these NVIDIA chips, and that gets passed to you, the consumer, who's going to be paying these, like $50-some per million tokens every time they generate some output from one of these proprietary models. So I ask you again, do you not think this is something that American-based AI companies that are the frontier of AI development in America, should be concerned about? I think so. I think that the cost piece is going to be the next battlefield in which the AI wars are fought. And it's a very critical battlefield. It's not a battlefield where everyone's flaunting new and flashy features. It's a battlefield where people are trying to prove that they can do the tasks that they were already doing for you at a much cheaper rate. Because at the end of the day, money talks. Anyway, that's all for the stream today. I hope you guys, for